So, whether screen is visible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, we will go for another two problems on the theories of failure. So, we will finish up after completion of these two problems. Okay. So, we have calculated the dimensions. Okay. Still so by using theories of failure. So, now we can calculate what is the maximum stress it is going to induce in the component. So, when it is subjected to loads. Okay. And let us see whether we have a problem that type of or not. Okay, note down. ASAE (1045) steel rod of sigma y equal to 309.9 megapascal of 80 mm diameter of 80 mm diameter is subjected to so is subjected to a bending moment of bending moment of 3 kilonewton meter and torque T. Okay. Taking sorry taking factor of safety of 2.5, find the maximum value of torque that can be safely carried by rod according to maximum normal stress theory and maximum shear stress theory. Okay. So, in this case they have given dimensions, okay, as well as the allowable stress. Now, it is subjected to two type of loads. One is a bending moment, another one is a twisting moment. Now, bending moment load is given here. It has a value of 3 kilonewton meter and torque is unknown here. Torque is unknown. So, now you need to compute what is the maximum torque that can be transmitted based on the maximum shear stress theory as well as maximum normal stress theory. So, let us go for solution here. So, first you notify given data. Now, sigma y is given, it is 309.9 megapascal or Newton per mm square. Next, so dia of rod is given 80 mm. Now, bending moment is given 3 kilonewton meter. Torque T you need to find out, okay, and FOS is given, this is 2.5. FOS is given 2.5, right. Now, based on the diameter, you can calculate the bending stress Okay, you can calculate the bending stress, that is what sigma x. Okay, but T is unknown here, T is unknown. So how you are going to calculate here? How you are going to calculate? How you are going to get the value of tau xy? How we are going to get the value of tau xy? So let us go for solution here. Okay. So first we will calculate the allowable stress or working stress. Okay. So this is what sigma A or sigma E equal to sigma y divided by FOS. Now 309.9 divided by 2.5. So how much you got here? How much you got? Someone calculate and give the answer.
So 123.96 megapascal.
126.9. Okay, megapascal. 123.96.
123, sir.
Okay, so 123.96 megapascal. Okay. Next, so let us find out what is the bending stress here. Okay. So now bending stress. So sigma b equal to sigma x. This is equal to what? M by z. M is given, it is 3 kilonewton meter. Okay. Now z is what? Pi by 32 into 80 cube. So z equal to pi by 32 into d cube. Okay. Now let us find out what is the bending stress here. Rule number 15, what is the answer? Rule number 15.
Sir,
Huh.
59.67.
59.68.
Yes, sir.
Okay,
Yes, sir.
59.68 megapascal. So now you got sigma x. Now sigma y is 0, right? So now let us find out the shear stress. Okay. So shear stress. So tau equal to tau xy. This is equal to what? 16 t divided by pi t cube. So you have all these standard equation from data handbook. You can directly copy these equations. Okay, you can directly copy these equations. So now substitute 16 T is unknown here, pi into dq. Now you are going to get this shear stress equation in terms of torque here. Shear stress equation in terms of torque. Okay. Now you calculate how much you are going to get. Is it right?
Yes, sir.
9.95 into 10 to 4 of minus 60. Right? Now you go for the maximum torque, or you can go for just say torque based on maximum normal stress theory okay. So sigma E equal to, you note down from design data handbook. Okay. So design data handbook, note down equation, I think is 2.8a. 2.8a. So let us go for data handbook. Okay, now this is what 2.8a, you note down. So sigma E equal to sigma x plus sigma y divided by 2, okay, plus square root of sigma x sigma y minus sigma y divided by 2, it is a square, plus tau xy square. Right? Now let us substitute values. Okay. Let us substitute values. So sigma E is 123.96 megapascal. Okay, right value only. Now sigma x is what, a bending stress. It is 59.68 minus 0 divided by 2. It is a plus. Okay, it is a plus. Plus square root of 59.68 minus 0, it is a square, plus 9.95 9.96 into 10 to 4 of minus 6 t, it is a square. So now you calculate 123.96, I think you are going to get 29.8884, okay, plus now you are going to get in square root is what, 29.84 square, plus, so 9.96 into 10 to 4 of minus 6 square. Now you need to calculate TA. So how you are going to calculate? You just try. So whether it is go for a trial and error method or squaring on both sides, are you going to get the value? So just calculate how much you are going to get 12 ft here. It is all just cross multiplication using the powers here, using the powers. Is there anybody calculated?
Six 6.46 Newton to the power of 6 Newton meters, kilonewton meter.
6.6.
46 into 10 to the power of 6. 6.46.
Is it right?
6.46.
46. Hey, everyone got the same value?
Approximately near the same.
Yes, sir.
How you will solve? How you will solve? How you will solve? Squaring on both sides. Now let us go for solution here. Okay. So 123.96 minus 29.84. Okay. So on this side you have a square, right? So you are going to get some value here. We just square this one. Now square it is going to remove here, right? Right. So now this is what a square. I think now you can calculate. I think now you can calculate. Is it right? So now you calculate how much you are going to get. Whether you use the same method or different method. So who has given answer? Same. So now answer in book they have given 8.971 kilonewton meter. 8.9771, not a megapascal, this is a kilonewton meter. Pascal is only related to stresses. Keep in mind, Pascal is only related to stresses and pressure. Okay, bending moment unit and the torque unit are same. Okay, because in bending moment, what happens? You are going to calculate the load into perpendicular distance. This is what distance. This is what load. Right. Now value of load is Newton. Length is either you go for mm. Okay. So now what happens? Bending moment Bm equal to Newton mm or Newton meter. So about a torque. Torque is what? It is a radial distance, okay, which is going to cause turning of the section. R is the radial distance. This is a tangential load. Okay, F. Now this is what Newton. R is mm. Again, T is also in terms of Newton mm or Newton meter. Don't get confused. I think got an answer. Everyone got an answer. Everyone got answer. Okay, next to calculate according to maximum shear stress theory. According to maximum shear stress theory. So refer design data handbook. So notify equation number 2.8c. Let us check. Okay, maximum shear stress theory 2.8c. So let us notify. Let us notify here. Okay. So sigma E equal to 2 square root of sigma x minus sigma y divided by 2 square plus tau xy square. Now let us substitute. Okay, 2. Okay, this is how much? 59.84 divided by 2 square plus, so 9.96 into 10 to the power of minus 6t. This is also square. Now sigma E is 123.96. Okay. Now just square 123.96 divided by 2 square. This is equal to how much? 59.84 divided by 2 square plus 9.96 into 10 to the power of minus 6 t square. So now we calculate value of t. Okay, so 5.44 into 10 to the power of 6 Newton mm or 5.44 kilonewton meter. Okay. Now what is the maximum value that can transmit here by comparing both the theories of failure? Okay, so maximum that can be transmit is 5.44 kilonewton meter. So it is not possible to transmit 8.971 kilonewton meter. Okay, because the maximum torque can be transmitted based on the maximum shear stress series 5.46. Again, if you cross check the value of substitution of T in this maximum shear stress theory, so now the induced stress is going to exceed the allowable stress. Okay? Induced stress is going to exceed the allowable stress. Then you need to write a sentence here or a comment. So the maximum torque, you need to write a comment here. Okay, that is what maximum torque. So that can be transmitted by shaft is T equal to 5.44 kilonewton meter, right? You need to write a comment. Okay, note down. Everyone got the answer? You note down. Next, note down. A rod of 50 mm diameter a rod of 50 mm diameter is subjected to a compressive load of 20 kilonewton 20 kilonewton together with a twisting moment of 1.5 kilonewton meter. Full point. It is made of C40 steel. It is made of C40 steel with yield strength 328.6 megapascal. 328.6 megapascal. Full point. Determine the factor of safety. Determine the factor of safety according to maximum normal stress theory. According to maximum normal stress theory and maximum shear stress theory. So let us note down given data here. Diameter D is given, so it is subjected to axial load which is of a nature compressive. It is of minus 20 kilonewton. Okay, along with that one it is subjected to twisting moment of 1.5 kilonewton meter. Okay, so steel is made of it is a it is a C40 steel with a sigma y equal to 328.6 megapascal. Now you need to find out FYS. Okay, so based on the maximum normal stress theory and maximum shear stress theory. So can anyone summarize how you can solve this one? Can anyone summarize how we can solve this one? Otherwise you give the steps. Okay, compressive load as sigma x. So now area is given, okay, load is given, sigma x you are going to get, okay, this is what minus, right? Next, so now using twisting moment to calculate tau xy, right? Now what is the allowable stress definition? Sigma a equal to sigma e equal to sigma y divided by FOS, right? Right? Okay. So now FOS equal to what? Sigma y divided by sigma e. Okay. Now once you got the value of sigma x and tau xy, you calculate sigma e based on maximum principal stress theory, right? And now you calculate FOS equal to what? Sigma y divided by sigma e. Similarly, you calculate based on maximum shear stress theory. Got idea? You got idea? You got it or not? Now you refer the data handbook. Now in this case it is the direct substitution. So sigma x equal to what? Minus 20 kilonewton, right? Divided by pi by 4, 50 square. Okay. So tau xy is 16 t, 1.5 into 10 to the power of 6 divided by pi 50 cube, right? You are going to get a value here, not any unknown value. Known value you are going to get. But once you got these value, you calculate value of sigma e based on these two theories of failure. Then you calculate FOS sigma y by sigma e. Okay. So here also FOS sigma y by sigma e. So you take a 5 minutes or 10 minutes to solve it quickly. So I can ask anyone to share it on screen. So is there anybody solved based on maximum maximum stress theory, maximum normal stress theory? Rule number 20. Rule number 20. How much you got FOS based on maximum normal stress theory? ಈ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಹೇಳ್ರು ಎರಡು ವ್ಯಾಲ್ಯೂ ಅದಾವೆ ಬರೇ ಇಷ್ಟು ಟೈಮ್ ತೊಗೊಂಡ್ರೆ ಹೆಂಗೆ ನೀವು? So how much you got to sigma x minus minus 1.08, right? Next, tau xy, how much you got? tau xy ಎಷ್ಟು ಬರ್ತದೆ? Okay, now just substitute these two values here. you are going to get some value. Now this is equal to sigma e. ಎಷ್ಟು ಬತ್ರಿ ದೇಶಪಾಂಡೆ ಎಷ್ಟು ಬಂತು ವ್ಯಾಲ್ಯೂ ಅಮೋಘ ದೇಶಪಾಂಡೆ ಎಷ್ಟು ಬಂತು ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಯ್ತು ಸಿಂಪಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಅದಾವೆ $60.5 right. $60.5 or more. Okay, so now let us calculate FOS here. So sigma y is 328.6. Okay, so sigma e is 60.5. Now you are going to get the value of FOS. $16. Now similarly calculate based on the maximum shear stress theory. ಪ್ರಾಬ್ಲಮ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. ಹಿಂಗಾದ್ರೆ ನಿಮ್ಮ ಟೈಮ್ ಸಾಲಲ್ಲಿ ನೀವು ನಾಳೆ ಎಕ್ಸಾಮ್ನಾಗ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ಮತ್ತು ನೀವು ಇಲ್ಲಿ ಮಾಡ್ತೀರಿ ಅಂತೇಳಿ ನಾನು ನಿಮಗೆ ಟೈಮ್ ಕೊಟ್ಟಿರ್ತೀನಿ. ಇಲ್ಲ ಬಡ ಬಡ ತೇರಿ ಪೋರ್ಷನ್ ಮುಗಿಸಿ ಒಂದೆರಡು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ ನಾನು ಸಿಲೆಬಸ್. ನಿಮ್ಮ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋಕೆ ಕೊಡೋದಿಲ್ಲ. ಮತ್ತು ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಮತ್ತು ವೇಸ್ಟ್ ಅದು. ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಲಿ ಅಂತೇಳಿ ಟೈಮ್ ಕೊಟ್ಟಿರ್ತದೆ, ಮತ್ತು ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋದಿಲ್ಲ ಅಂತಂದ್ರೆ 2 ನಿಮಿಷದ ಕೆಲಸಪ್ಪ. 2-3 ವ್ಯಾಲ್ಯೂ ಅದಾವೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಹೇಳೋಕೆ ಎಷ್ಟೊತ್ತು ಮಾಡತ್ತೀರಿ. So now you calculate how much you are going to get here. You refer from design data handbook equation 2.8c, right? You substitute here. Now how much you got sigma e here? $122.65. Is it right? Whether formula is right or wrong, you first check it. Formula is correct? Okay. Then Fy is equal to 328.6 divided by 122.65. Okay, how much you got here? 2.6, right? Right, so FOS based on maximum normal stress theory. It is 5.42. Okay, so FOS based on maximum shear stress theory, which is 2.6. Okay, so now we'll finish this chapter. Next chapter is what is stress concentration. Okay, so next chapter is stress concentration. So what is the meaning of concentration? What is the meaning of concentration? General meaning. I don't want exact meaning of concentration in engineering. Focusing on that point, right? Next, any other meanings? ಮತ್ತೆ ನಾವು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂದರೆ ಸ್ಪೆಸಿಫಿಕ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಮತ್ತೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಡೋದು ಅಂತಾರಲ್ಲ, ಏನು ಹಂಗಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೊಡ್ಬೇಕಲೇಪ್ಪ ಅಂತೇಳಿ ಮಾತಾಡ್ತಿರ್ತಾರಲ್ಲ, ಏನು ಹಂಗಂದ್ರೆ ಹಾಂ one thing, one thought. So concentration means you try to accumulate all your focus, all your energy to do particular work. Okay, similarly, if you come to stress concentration factor, so some components are in a such a way that they are going to contain maximum stress concentration at a particular location. Okay, so we will discuss this stress concentration tomorrow. Okay, I will just give the attendance in chat box.